One of the most important things to understand about maps is map scale. Map scale represents the relationship between map distance and ground distance. You're looking at the relative sizes of an object on the map in reality. It can be understood as the ratio between map and ground distance, and this can be described in three different ways, either through a representative fraction, through a verbal scale, or through a graphic or scale bar system. And first of all, with the example of representative fraction, the numerator is always 1 and always represents map distance. The denominator represents ground distance. So in this case, 1 inch would represent 62,500 inches, which would mean a map scale of 62,500. We always use identical units to describe map scale in this way. So again, 1 inch represents 62,500 inches, or 1 centimeter represents 62,500 centimeters, or in case you've watched all 5 or 6 of these lectures, one right after the next, 1 bottle of beer represents 62,500 bottles of beer. You're never going to say 1 inch represents 62,500 miles. For one reason, that is completely impossible because the Earth is only 24,000 miles in circumference. And another way to look at scale is by doing it this way. The denominator basically can be used then to describe what our scale of reduction is. In other words, in this case, we're reducing the scale of the Earth by 62,000. Another way to describe map scale is through the use of a verbal or written scale or a word statement. So for example, if you had a map where 1 inch equals 63,360 inches, a shortened way to say that would be 1 inch equals 10 miles. And so that would represent a graphic scale that would look something like the one here on the slide, or a representative fraction that looks like the one below, 1 to 63,000. Verbal scales are basically descriptive ways of presenting scale, such as making a statement like 2 inches represents 2 miles. Other examples of verbal scale might be this. If you had a map with a scale of 1 to 63,360, this would be the equivalent to 1 inch represents 1 mile, and that's because there are 63,360 inches in a mile. If you had a scale of 1 to 126,720, this is 1 inch represents 2 miles. 1 to 24,000 would be 1 inch represents 2,000. Scale bars are an effective way to present scale on the map that allows for easy measurement. And there are some basic ways of doing a scale bar that may depend on the type of map being made. And so first of all, scale bars are used to present, again, and to be able to compare and measure distances on the map. So you would need then to determine distances in whole units and fractions of a unit. And again, those depend on the type of map being made. 0 could be positioned in the center of the scale bar or to the left, and then you would have sub-markings that would go from there. So here are some examples of different types of scale bars using kilometers, statute miles, nautical miles, and so on. And there are different ways of subdividing and putting the scale bar onto the map. In some cases, you might have kilometers on the top and statute miles on the bottom, as is shown in the example on the slide. The advantage of a scale bar is that it will reduce and enlarge with accuracy, and we'll see that in different applications in GIS. And scale bar may be both miles and kilometers on the same bar. This is what's called a stacked scale bar. And also it can be useful in calculating and estimating distances on a map. Another type of scale bar is a variable scale bar, and this happens to be an important choice where you have different levels of scale in different parts of the map as a result of map projections. A little later in the semester, you'll learn about the Mercator projection, which is what we call a cylindrical projection. And it has the advantage of keeping shape to be true, but it distorts area, especially as you move to the north and south away from the equator. And so as a result, a position at 60 degrees north on the globe would have a great exaggeration of area as a result of the stretching of the globe and how it's represented. So you may have seen a scale bar like that that's variable and has. We can describe map scale as either large scale or small scale. Large scale maps will show less area and more detail. For example, 1 to 10,000 would represent a smaller denominator than a map with a scale of 1 to 1 million. In the same way, a larger fraction, 1/4, is a larger number than 1/1,000,000th. So 1/10,000th is a larger number and a larger scale than 1/1,000,000th. Small scale maps would show then more area at less detail. For example, 1/10 millionth, that might be a map of the state of Ohio, and with a larger denominator by comparison and a smaller fraction. Medium scale maps are somewhere in between, and there are really no set limits that determine large scale. It's somewhat arbitrary. Here are examples of how we scale into geographic areas. In this case, the Pacific Northwest is the smallest scale map, and the largest scale map is the map of downtown Seattle. In your topographic mapping lab, you'll do some measurements using map scale and some of the basic principles, and there are more instructions in the lab. It basically takes advantage of some basic conversion factors, so you'd want to think about how many inches there are in a foot, how many feet there are in a mile. There are 63,360 inches in a mile, for example, and 1 kilometer is 100,000 centimeters if you end up working in metric. I don't think you will in this particular lab. But in any case, there are some good examples, and some of the first questions in that lab take you through that. So I take a look at that and then kind of pay attention to the guidelines and work through that for the first several questions of the lab. So that concludes the overview of map scale, large and small scale maps, and the use of different types of scale in a map.